Okay, my friends. So that was great. 10 games, whatever. But I argue that it's not enough to really see what's going on. I mean, we have maybe a hunch as to what we should be doing right now. But 10 games, I mean, I think I've told you before that I flipped coins 10 times and gotten 8 heads and 2 tails, which is not a very good indication of what's going on with a coin flip. So I was going to use the same simulator and just keep playing it, you know, thousands and thousands of times, but I realized that I actually could probably build a more efficient one. So that's what I did here. Let me break it down for you here. The contingency table is going to be here, which is the same. It's going to look exactly the same as it does in your project. Let's try that again. It's going to look the same as it does in your project, except it's going to be updating with the data from the simulations that I'm going to explain to you now. So if you look at the prize is behind, what Excel is doing is generating a random number between 1 and 3 to put the prize behind a door, which is exactly what the website did. You choose, whatever door you choose is the same thing. It's a rand between 1 and 3. Now, this is the fun one. Monty shows you. He has to show you a door that A, doesn't have the prize behind it, and B, that you didn't choose. And this was actually super fun to code. I'll click on the cell so you can see it. It's easy if you pick the wrong door, right? So like if you pick the wrong door, he has to show you the only other door that has a goat behind it. But if you pick the right door, like I did here, like for example, the prize is behind 1 and I chose 1, that means there's 2 doors for him to pick from and he has to randomly pick one of those. And that's the mathematics up there that actually helps you do that. It was a fun little math problem to figure out. The switch is based on a random number. I flipped a coin, random number 1, 2. If it's a 1, don't switch. If it's a 2, do switch, okay? Or back, I forget which way I did it, but it's tied to a random number. And the result is simply if you made the right choice. I've got the decision over here in cell A8 as a logical. It's kind of a mess up there. But if you're interested in the spreadsheet, I can send it to you. So right now, here's what happened. The prize is behind door number 1. I chose door number 1. Monty showed me door number 2. I decided not to switch. Well, since I picked the right door and I stayed, that means I won, and that's why there's a 1 out here. Let's play again. Okay, so this time the prize was behind 2. I chose 3, which means he has to show me 1. But I chose not to switch again. I must have flipped the same thing this time. By not switching, I lost because remember I chose 3, but it was behind 2, and that's why I stayed and lost. Let's play again. Okay, same thing happened there. Stayed and lost. That I'm repeatedly staying so far. This kind of happened on the simulator we did online too. Okay, there's one where I switched and I lost. The prize was behind 3, and I chose 3, and then I chose to switch, so I switched off of it. Okay, and then so you can see what's out. Here's one where I switched and won. So what I'm going to do is I'm going to hold down this randomizer button and let it go and play lots and lots and lots and lots of games.
I do not suppose you could speed things up.
As you wish.
I cannot believe I actually got that to stop at 10,000. Yay! Okay, let's use this contingency table and have you practice some probabilities of your own.